All right, so we're still working on Unit 1 exam questions. So this next string of problems we're going to do, they want you to simplify, but keep the exponents in your answer. So when they say simplify, they just mean make it as simple as possible while still keeping the exponents in there. So for example, if you had -6 to the second times -6 to the -10th times -6 to the 5th. So since we have the same base, we can just add these exponents. That's one of the first exponent rules that we learned. So I'm going to keep the same base of -6, and I just need to add the exponents. 2 plus -10 is -8. -8 plus 5 is -3. So this is my simplified answer, or this is what they want you to write, the simplified answer of this longer problem. So I kept the exponents in there. Another one you might have to simplify would be something like 3 to the 4th power over 5 to the 7th power, all of that raised to the 3rd power. So because they're different bases inside here, I cannot use the quotient rule and just subtract the exponents because these are different bases. But what I can do is the power of a power rule. This 3 is going to be applied to both of those exponents. So I'm going to rewrite this as 3 to the 12th power. I multiplied those exponents over 5 to the 21st power. And that is as simple as I can put it with the exponents because there's nothing else I can do since they have different bases. Let's look at another one. If I had 8 to the 1/2 power times 8 to the 2/3 power. So again, these ones do have the same base, so I can just add the exponents. So to add 1/2 and 2/3, remember you'd have to get a common denominator. I'm just going to go over here and add 1/2 plus 2/3. So I'm going to use the common denominator of 6. So 1/2 is the same as 3/6, and 2/3 is the same as 4/6. So when I add these fractions, I get 7/6. So 8 to the 7/6 power. You could, if you'd rather have a mixed number, 8 to the 1 1/6 power, but normally I think they would probably leave it as an improper fraction for exponents. Another one to simplify would be something like 3 to the 2/3 power over 3 to the 1/4 power. So since I have the same base, I can just subtract these exponents. That's the quotient rule. So I have to do 2/3 minus 1/4. So again, I have to get a common denominator. So I'm just going to come over here and do my scratch work. I'll use the common denominator of 12 again. So 2/3. Oh, I used the common denominator of 6 up there. But here I'm going to use 12. This is the same as 8/12, and this is the same as 3/12. So 8/12 minus 3/12 is 5/12. So my answer is 3 to the 5/12 power. Another one to simplify, 6 times 3 to the 4th power, all of that raised to the 2/3 power. So I can't do anything inside the parentheses right now because they don't have the same base. So I can just apply the 2/3 power to each of those problems. So I would have 6 to the 2/3 power times 3 to the, now I have to do 4 times 2/3, which comes out as 8/3. And that's as simple as I could put that right now, leaving the exponents. One more. If we had 7 to the 2nd power over 5, all of that raised to the 9/10 power. Again, I can't do anything inside the parentheses because they don't have the same base, but I can apply that 9/10 exponent to both the numerator and the denominator. So that would come out as 7 to the 18/10 over 5 to the 9/10. And that's as simple as you could put it, keeping the exponents the way that they are. You could simplify this 18/10, I guess. You could simplify that to 7 to the 9/5, just to have a reduced fraction. So that is how you simplify those guys, keeping the exponents in the problem.